Okay, we will start. Before we continue on, we will be doing this question. Okay, exercise 3.4, question number 2, Roman number 3. But before we do that, I'm going to show you an example question which is very similar to this. Okay, so when we talk about two-digit number, okay, the problem with two-digit number is that suppose if I write xy, then x, if x value is suppose say 8, y value is 5, then when I write xy, the sign between them is multiplication. So what happens is when I write these two together, it will become 40 instead of 85. It will not become 85, but instead it will become 40 because 8 into 5 will be 40, right? So whenever they are saying two-digit number, okay, we cannot assume it to be the two digits to be x and y. So the only way to do this is to use the expansion method. Expansion method means in lower grade you must have studied where suppose 243. So if 243 is there, we can write 3 as 3 into 1 plus 4. We can write it as 4 into 10 plus 2. We can write 2 into 100 because 2 is on the 100th place, 10 is on the 10th, 4 is on the 10th place, and 3 is on the 1st place. So that way 200 plus 40 plus 3, 200 plus 40 is 240, 240 plus 3 is 243. So 243 can literally be written like this, right? So that is called the expansion method. So if I wanted to write 85 with two-digit number, then I can write this as 8 into 1 plus, since 8 is on the 10th place, we'll be writing 8 into 10. Okay, so this is what we're gonna do. We're gonna take the 10th place. So let the 10th place be x and the ones place be y. The 10th place is x. So like here, the 10th place is 8. So 8 is multiplying with 10. Likewise, we will multiply x with 10 because x is in the 10th place and 5 is on the 1's place. And since 5 is in the 1's place, we multiply 5 with 1. So just like that, y, if we take it as 1's place, then y into 1, right? So here also, therefore, required number will be equal to 10x plus, or you can say 10 into x. Okay, let's write it like this so that you will understand next time. X into 10 plus y into 1. X into 10 because it's the 10th place, and y into 1 because it's 1's place. So this will become 10x plus y into 1 is y. So the required number is gonna be this. Okay, now in two-digit questions, okay, if whenever they say there's a two-digit number, there's always going to be reciprocal, or not reciprocal, but the digits interchanging. There is always going to be there. It has to be there, otherwise you cannot make two equations. Okay, so like for example here, the number obtained by reversing, they're either going to reverse the digits or they're going to interchange the digits. So what does it mean to reverse or interchange? It literally means 85 will be written as 58. Got it? So the 1's place jumps to the 10th place, and the 10th place jumps to the 1's place. Okay, so I'm gonna write reversed number equal to, remember, I'm not writing it as digit, I'm writing as number because we're talking about a two-digit number. So when I write digits, it literally means this and this separately. For example, 85, the two digits are 8 and 5. 8 is separate, 5 is separate. So, but when I'm referring 85 as a whole, 85 is a number. So 85, we write it as a number. Okay. So by reversing the digits, we will get 58 in this case, which is 5 into 10 plus 8 into 1, right? So we just replaced 8 with 5 and 5 with 8. So the same thing will occur with x and y. So this will be y into 10 plus x into 1, which is 10y plus x will be our reverse digits. Okay, So whenever there's a two-digit number, you're always going to be doing this. You're going to take the tens place and the ones place. After that, you're going to find the required number, which will always be same. So whenever there's a two-digit number, up to this step, everything is going to be same. Up to this step, whatever question it may be. Okay, even if it's not something which is included in the textbook, if it comes from outside the syllabus also, up to this step will be same for every question, because we'll have to take ones place ones, tens place another variable, and then we have to find the number and the reverse number also. And then up to here same, and then we're going to start according to question, what the question is asking us to do. Okay, so up to here same, and from here according to what the question is saying. So guess what, the sum of two-digit number, so sum of a two-digit number, so the number, okay, sum of the two-digit number and the number, again number obtained by reversing the digits. So this is a number, this is a number. So sum of the two-digit number is this, two-digit number is this, right? Required number, the two-digit. Let's write required two-digit, required two-digit number, so that you won't get confused. So required two-digit number is this, 10x plus y. So 10x plus y, the sum of two-digit number and the number obtained by reversing digits. So this plus this. So this is the two-digit number. This is the number obtained by reversing the digits. So sum of these two is 66. That's what the question is saying. Okay. So let's try to solve this. X, see, this is bracket, but outside the bracket there's no number, so it will remain the same. And this is positive, so it will remain the same. So 10x plus y plus 10y plus x equal to 66. 10 plus x is 11x plus 11y equal to 66. We can take 11 common. Like, it's not compulsory for us to take common, but if we take common, at least it'll become a little easier now. X plus y equal to 6 is our equation 1. Okay, so let's try and make equation 2. Up to this much, I hope you understood. Now for equation 2, they're saying if the digits of the number differ by 2, which means in this case the digits, see, I've already told you, whenever they say number, it means the whole thing, the two-digit number, 85 ki number condition. But when they're saying digits, it means the separate digits. Got it? So they're saying if the digits of the number, so the digits differ by 2, in this case the digits 8 minus 5 has a difference of 3. So in likewise, when the digits are subtracted, they yield a difference of 2. Got it? So in this case, I took an example of 8 and 5, but I told you 8 can be represented by x, 5 can be represented by y, so it's like x minus y only, right? So second case is, they're saying if the digits of the number differ by 2, so digits are x and y. The tens digit is y. So this part, see, there's two possible outcomes. Okay, one is you can do y minus x, one is you can do x minus y, because they did not say in the question what was larger. They did not say the tenth digit is larger. Say, for example, I told you it's 85, right? So I can do 8 minus 5 equal to 3, or even if it was 58, the difference between the digits is still 3, right? So we don't know which one it is. So you can literally take x minus y or y minus x, doesn't matter. Okay, so suppose, so like if you take x minus y equal to 2, then it's like opting for one of the options, the other one will be left out. So when you get the answer, after getting the answer, you're just going to reverse this one and then show that it has two possible outcomes. So these are second equation. This much you got it, nah? The difference, the digit of the number differ by 2. So difference of the digit differ by 2. So this is equation number 2. We have equation 1, equation 2 here. We can add 1 or 2, subtract 1 or 2, doesn't matter. Subtract 1, subtract equation 1 minus equation 2 directly. Why? Because x and y value, everything is same, nah? So x plus y equal to 6, x minus y equal to 2, and then we're subtracting, so this will become minus, this will become plus, this will become minus, this will cut off, this will 2y, this will 4, y equal to 2. So from we can put in equation 1 or 2, doesn't matter. I'll put in 1. 1 is x plus y equal to 6. Y we got 2, so x plus 2 equals 6. X equal to 6 minus 2, x equal to 4. Therefore, the required number, what did we take the required number as? 10x plus y, na? 10x plus y equal to 10 into x to 4 plus y to, how much you got? 2, which is 40 plus 2, 42. So therefore last thing itu boleh record as that, because see 42 we got, but I've already told you there's two possible outcomes. We could have done y minus x minus y and y minus x, na? Therefore total possible outcome equal to 42 and it will reverse to 24, which means, see, it'll all make sense right now. See, 42 and 24 we got now. 42 or 24. Sorry, this should be or 42 or 24. Okay, so if it's 42, when is 42? Okay, it says the number and the number reversed is 24, added together becomes 66. So 66. If we take this, the number and the number reversed added up will become 66. In both cases, it's coming up to be true. So both are right answers only. Okay. So possible outcomes are that and that. So let me okay. So that's it. The next question is this. So I'm gonna do it really fast. I wanted you to do it, but I don't know if you can do it or not. So this is a very similar question. Okay, so as I've already told you, like up to here you will be doing the same thing. Up to here, from here till here you will be doing the same exact thing for the next question also. So you will get the 10th place is x, 1's place is y, recurrent number is 10x plus y, and reverse number is 10y plus x. So I'm going to do shortcut. Okay, now so it's x 3.4. Question number 2. So the sum of the digits, remember, whenever they say number, it means the whole thing 10x plus y or 10y plus x. But whenever they say sum of the digits, only the digits, it means x or y. Okay, digits means x or y. And number means the whole formula thing. Okay, the sum of the digits of a two-digit number is 9. So sum means plus value digit to 9 as it was. Equation 1. Also, I'm doing shortcut, okay, because already told you so much in MCQ. 9 times this number. So 9 times, this is case 1. This is case 2. So 9 times means multiplication. This number, 9 times this number means the required number, which is 10x plus y. Is means equal to twice the, so 2 times number obtained by reversing the order. So reverse number is 10y plus x. Which is not what I hope you understood that. So 9 times in multiplication. This number means the number which we number is means equal to 2 times 2 into the number obtained by reversing. So number obtained by reversing is this one. So if we open the bracket, 90x plus 9y equal to 20y plus 2x. If I take 2x aside, it will become 90x minus 2x plus 9y minus 20y. Since nothing is left here, I took 20y also this side, 2x also this side, so also 0 will be left. 88x minus 11y. I can take 11 common. 8x minus y equal to 0. 11 I send it this side, it will become 0 only, because any 0 divided by anything is 0. So equation 2. So see, I'm gonna do a very different. You can do the normal method I showed you, okay, making x and x same. But elimination, it does not restrict to only x's. You can even make the y and y same also. It doesn't matter. So, and second thing, the second rule is it does not restrict to subtraction on the equation 1 minus 2 rule. Like you can add it up also. But the priority is that at least one variable should be cancelling each other out. So if even if you add or subtract, if x and x are cancelling each other, then you're doing the right thing. But after adding or subtraction, you're getting both x and y, then you're doing the wrong thing. That's the rule, okay, in elimination method. So this is what I'm going to do, since you all ought to know how to do this also. Equation 1 plus equation 2. Why I'm doing it is because if I subtract, okay, equation 1 and 2, this equation 1, equation 2 is this. If I subtract, the signs will change, but when I add, the sign does not change. Got it? One it is sign opposite, 8x la plus ho jabo, itla plus ho jabo, itla minus ho jabo. I mean 8x la minus ho jabo, itla plus ho, itla minus ho jabo. That happens only when you are subtracting equation 1 and 2. Got it? When you are subtracting equation 1 and 2. But this time I'm adding equation 1 and 2 because this is already addition and this is already subtraction. If I subtract, this will become addition and it will not cancel out. So since I'm adding, this addition subtraction has to cancel out, it will plus 9x. This will become 9 plus 0 is 9. So we can cut this, so x equal to 1. So from equation 2, 8x minus y equal to 0, or instead of x, if I put 1, it will become 8 into 1 is 8, only minus y equal to 0. If I send y this side, 8 equal to y. So we got y, we got x. Therefore, number is equal to, we took 10x plus y, right? So 10 into 1 plus y. Y is 8. So I'm just going to put 8. So 10 into 1 is 10 plus 8 is 8. Got it or not? So second thing, I told you that in this question there was 2 answers, right? We got 2 answers because of this thing, 42 plus 24, right? So we had to write both. In this case we cannot do both. Why? Because if you try to equate this one and put it here, it will not satisfy this 81 if it's 81, because 81 into 9 will tower 18 into 2 will jutik. But if you do 18 into 9, it becomes big, and 81 into 2 it remains big only. Okay, so you have to put it in the condition they've given us and see if it satisfies that or not. If it satisfies that, then it's right, but if it doesn't satisfy that, then but the thing is, you don't have to show the calculations or anything, so that's fine only, I guess. Now let's do one last question. Mina went to a bank to withdraw 2,000. She asked the cashier to give her 50 and 100 rupees notes only. So let me tell you the concept. If you have, suppose 4 50 rupees notes and then 3 100 rupees notes, then how much money do you think you'll have? You'll have 50 rupees chata tagiro, 200 jo, right? 200 rupees total, 300 rupees, 100 rupees in tagiro, 300 jo. So you'll have a total of 500 rupees, right? So we'll try to use this concept, okay? So we will take, let 100 rupees, 50 number of 50 rupees note be x and number of 100 rupees notes be y. Okay, so now we're taking this as x and this is y. Remember, this was this, that's why we multiplied this and this and got this, right? We multiplied this and this and got this, and then we added these two. So now that 4 is replaced by x, we're gonna multiply 4x and 50. So case 1, just like how we did here, 4 into 50 kurishina itu nishina ite 4 x per plus x into 50 aja. So x into 50 plus, sorry about that, x into 50 plus y into 100, right? So itu duita multiply kurisi plus kurisi paise, itu duita multiply kurisi plus kurisi paise, inner itu duita plus kurisi na last na. So itu total illa total plus kuro. In this case they're saying that Mina went to withdraw 2,000 rupees in total. So the total is 2,000. So that's our case 1. Or we can take common. You can literally take this case one, okay, but just to make calculations easier, it's always better to take common. So we can take 50 common. So x plus 2y, because 52 is 100, 2000. We can cut 0, 0, 5, 1 there, 5, 4, 0, 20, 0. So x plus 2y equal to 40. See, I'm cutting this because there's no, it's like multiplication 50 into something equal to 2000. So since there's nothing but multiplication, then and only then I can cut, okay? If there's even a single addition or subtraction here, if it was x plus 50 into this, we cut you only when there's only multiplication present there, then we can cut this and this. To break it up, we totally key as it is common local one. So this is equation 1, case 2. For case 2, okay, this question again, let me show you this. I said there's 4 50 rupees notes and 3 100 rupees notes. Nah? So overall, I have a total of how many notes? 7 notes. Right? I have a total of 7 notes. So just like that, she got a total of 15 notes. 25 notes, sorry. 25 notes in total, but I took the number of 100 rupees note to be x and the number of 100 rupees 50 and 100 rupees to be x and y. So in total she has 25 notes. So if 4 la x likina 3 la y likina, so now 4 plus 3 is 7. Just like that, x plus y is the total number of notes, which is 25. So these are equation 2. So here we can do equation 1 minus equation 2. It's going to be easy, this one calculation. Subtract these two cuts off, this becomes y, this becomes 15, and then putting this one in equation 1 or 2 doesn't matter. I'll put it in equation 2 from 2, x equal to y goes ahead, it becomes minus now, so but y is 15, so minus 50, x equal to 10 na. So that's it. So she got 10 50 rupees notes and then 1500 rupees notes. Okay.